Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode that is waiting for us. So let's get started. Yep. So today we have this question that is of minimum index of a valid split. So yeah, that is, I have to say, quite easy questions that we are solving from last couple of days. Compared to that, it is quite easy to get the gist and implement it out. Yeah, so let's understand the problem statement first. So on problem statement, we have given an elements x on an integer array a of length m is dominant if more than half of the elements of ARR have the value x. So it's quite straightforward. So if an elements x to a dominant array is said to be dominant if its length is, let's suppose, n, then more than n by 2 has a particular elements x. If that is the case, then these elements more than is half, then these elements is known as the dominant elements. Yeah, apart from that, they have given a zero index integer array nums of length n with one dominant element. So the initial array, the nums they have given to us, is already a dominant array. Now what they are asking, they are basically asking to split it at an index I into two array, nums of 0 to I and from nums of I plus 1 to n minus 1. That is, we have to split it in a two half. Basically, you can choose an index I. The index I can be any of, like, from 0 to n minus 1, and in the valid split there is certain conditions. So your I value should be lie from 0 to n minus 1, and your first segment and your last segment, you after splitting from a middle, you must not a middle, after splitting from any I index, you have two halves. One half have elements from 0 to I, and another half has elements from I plus 1 to n minus 1, have the same dominant array. So after splitting them, both the segments should have same dominant array which the master array have at, that's the first show. Now here nums, they are basically stating what means from nums of I to j. I think we all know that is a sub-array from starting at index I and ending at index j, both ends being inclusive. So that's we all know, and particularly if j less than I, then that is an empty sub-array, that we all know. And return the minimum number of valid split index. If no valid split index exists, then return minus 1. So at big 2 we know, at max we can return, like, altogether the indexes in minus 1. So like very last index, then one elements till from one segment is the entire first segment. So the first segment is the entire array and the last segment is an empty array. But that split is not allowed, right? That split is not allowed, because if we do that split, then altogether we are violating these conditions. Our last segment should have at least one elements by these conditions. And if we are not able to make such split, then we can return minus 1. So I think question is very straightforward. And what actually, like, after reading the problem statement, what is actually coming to top of your mind? So first of all, though, we have no choices, because we know the given array is a dominant array, and after splitting the array into two halves, first half and second half, which is the dominant array is given to us in the nums. So nums is altogether dominant. So after splitting to a certain index from 0 to n minus 1, 0 to in between n minus 1, I have to say, so that is also the dominant array should be that elements, because otherwise there is no chance, because we have given an array with one particular elements as a dominant array, and we do some splitting, and we can say that on first split dominant array is x, and on last split dominant array is also x, because both of the split has same dominant array, but which is not equals to the dominant elements which is given to our resultant array. That is obviously not, by very standard intuitions we can say that is obviously not going to happen. So the dominant elements which is on the parent array or the given array should be the dominant array of the two split that's the like very intuitively we can say that is the because other elements are less than our dominant array, right? So if we do splitting on any way, how they can like beat the dominant altogether the existing dominant elements? They can't even do any of the segments. Let's suppose a particular element is a dominant, how it is able to beat the existing dominants array? So that is never going to be happen, never. That is very standard intuition. So initially what we have to do, initially we have to find who is the dominant elements. I think that we can do in very standard iterations over the array, So I am stating like you guys are able to identify the dominant array altogether in the elements. If not, then I am just quickly giving you a brief on that, how you can identify a particular elements, which particular elements is a dominant array. So you can consider, wow, it started crying. So what we have at, so if we have if we can carry a dictionary, and dictionary of each basically holding the count, how many times this particular array elements has occurred, and we can run a for loop, for each in nums, the given nums, and we can do a d of each plus equals to 1. So that's the count of how we can generate the frequency map. So that is the very standard things of generating the frequency map. And let's suppose we are also carrying the current dominant elements total count, so we have two more variables, total count. So basically my requirement is after doing a single iterations on this array, I should be able to point out my dominant array and also its count. So that is my initial requirement. So we have total count initialized as 0, and my elements element is, let's suppose, is also 0. So if this d of each at any particular point of time is more than my total count, then for sure I can do my total count is equals to d of each. We can store it d of each here, and apart from that we can also overwrite our elements. We can also overwrite our dominant elements to each, as simple as that. After doing this entire for loop executions, after this entire for loop executed, we have our dominant elements ready, stored at elements variable, and its count stored at count variable, total count variables. Now what we need? So let's suppose if you are standing to any particular index i, so what actually you are looking for? So we need two things. We know what is the length of this particular segment. It is nothing but n1. If I consider it is an n1, so that is the length of this particular segment is I plus 1, because I is 0 index based. Very intuitive. And what is the dominant count, or more specifically I have to say dominant left count we have at to this particular segment. So for that we can also carry a dominant left count. So when we iterate over the array, when we iterate over our nums array, second iterations we will do. So if this particular elements, if my nums of I is equivalent to our element, because on initial go we have identified our dominant elements. So if it is equivalent to our dominant elements, so we will do our dominant left plus. So like this way when we are standing at a particular index, I, we know the total size Total size is what? Total size is n plus I. Sorry, I plus 1. I plus 1 is the total size of the left segment, and dominant left is nothing but dominant left is going to be provided by this particular variable. So what is like non-dominant then? What is the non-dominant then? So can I say what is the total size? We know the total size. Total size is nothing but I plus 1. So that is the total size of this particular segment. Then what is the non-dominant count? So non-dominant is minus of total size minus dominant of left. I can write that is very straightforward. So that is of non-dominant of left. So I plus 1, that is the total size of the left, and minus of dominant left. I can easily write it. So like this way on this particular segments I know dominant count here on this dominant count, and I also know non-dominant count. So these two things we know. So now can I say this particular segment is valid or invalid? How we can check? If my dominant count is greater, so my dominant count should be greater. If that is the case, can I say this particular left segment is valid? What about the right segment? How we can say this right segment is valid or not? How we can say? What then? We have to know what is the total elements to our right. What is the total elements to our right? We know. Now let's identify that. So what is the total elements we have in the entire array? Entire array is n. On left, how many elements? Is I plus 1. So if I remove I plus 1, so that is my right segment size. These things is my n minus I plus 1. So this is my right segment size. That is very intuitive. So how? Because we have total n elements on the array, and left segments has I plus 1 elements, so n minus I plus 1 should be my right segment size. And can I say now what is then right dominant count? On the right segment, how many dominant elements we have at? What is the right dominant count? If so, I know how many dominant elements count in the first go. How we can get it? From total count. The total count variables basically stored how many total dominant elements to the entire array, and we know before we just calculated what is the dominant left count. So if we just minus them out, total count minus dominant of left count, so we will get our dominant of right count. And what is the non-dominant of right? I think very simple. We know how many elements in the right segment, that is of n minus I plus 1, we just defined. And what is the dominant count we have in the right segment? We just do it in the right dominant count. So if I can minus the right dominant count also from the total elements on the right segment minus of right dominant count on the right segment, we will get our non-dominant count on the right segment. Now if we have all four variables, which for dominant count on left, dominant count on right, non-dominant count on left, non-dominant count on right, can I compute my answer? Can I say if that particular split is valid or invalid? Can we say? I think yes, obviously yes. So what is the condition? My dominant left count should be greater than my dominant right count. So this, if I can write it 1, 2, 3 and 4, so my 1 should be greater than 2. Dominant left count should be greater than my non-dominant of left count, and my dominant right count that is of 3 should be greater than my 4 that is of non-dominant right count. Can I say this particular index where I am staying, can I return this? Yes. And if the entire executions we are not able to build these particular conditions all together to the entire go of nums, then after that can we return a -1? Yep, We can obviously we can. Yeah, so that is the like entire intuitions of this particular question, guys. So let's just quickly understand the problems, like code iterations one. So we defined our length of the nums, and we have initialized our default dict as for other for frequency count map, you can say it. And we have the elements, which is the dominant elements, and the total counts of these dominant elements. And we are doing the very standard things we just explained on the one note. We are iterating over the nums, and we will do of d of each plus 1. And if at any particular times my this particular element's frequency is more than my total count, then we will update our total counts to d of each, and we will store this particular elements, this part each is the elements is the dominant elements. We stored it in our dominant elements, and then we did the exact thing, same things we just explained on the one note. So we start only one variable's dominant count on left with 0, and what we are doing, if we are iterating from left to right, and we are checking if that nums of I is equals to element is what, the dominant elements on the parent array or the given nums array. If that is so, then we are increasing our dominant count on left. Now the exact same formula. What is the non-dominant count of left? I plus 1 minus dominant count on left. What is the dominant count on right? Total dominant counts we have at minus dominant counts on left. What is the non-dominant count on right? What is then? Here is two things. What is the size of the right part? That is of n minus I plus 1 minus of dominant count of right. So then on that case we will get the non-dominant count on right. So that is exactly same things what we written on the one note. That is n minus I plus 1 minus right dominant count. Like this way we are getting our non-dominant count. The exact same things I have written over the code. N minus I plus 1 minus dominant count on right. So now the very two cases, if dominant count of left is greater than my non-dominant count on left, and if my dominant count of right is greater than my non-dominant counts on right, if that is so, can I say it is a valid index? Yep, we can. So we are returning I from here, and if the entire iterations we are not able to do so, then after that we are returning a minus 1. Yes, so it is as simple as that, guys. And now quickly discuss the time complexity. I guess on time complexity we are doing 2 standard iterations only, so that is for sure of big O of 2n, not more than that. And on space part we are only using one frequency dictionary, then on that case it is going to be big O of n. Just quick small one note I have to say, that is of this particular questions can be solved is one of the popular algorithms known as Moore-Voti algorithms. You can learn it from online. So Moore-Voti algorithms. So which is basically giving you if they have given a dominant elements, this Moore-Voti algorithms can give you the dominant elements, which is our case the elements. So by single iterations it can giving you. So how it is doing so on very high levels, it is basically maintaining a count. It is basically nullify the counts if you are choosing a particular elements as a dominant elements, and if you encounter the elements which is not equals to your dominant count, then you nullify the count of the elements that you have chosen your dominant elements, you have nullified. And if at any particular of time, if your like count is like dominant elements count is equals to 0, just by nullifying the things, so that means you the current elements you are going to choose this as a new dominant element. So like this way it is able. So if you are not able to understand, please make a comments. I will make a separate video of Moore-Votis. But the point is, if for Moore-Voti the time complexity is going to be higher from the what we have implemented. So that's the reasons I didn't implemented these solutions Moore-Voti, but for like knowledge purpose I am giving you the like the taste of what is the time complexity of Moore-Voti. So for Moore-Voti, you on the first go you are able to identify what is the dominant elements, but you are not able to pinpoint what is the count. So to identify the counts you will still need one more iterations. So the time complexity is going to be 3n, because very simple, like on if we are carrying a dictionary so we have the power to identify the count also. We are able to identify the element also in the one go, but count also we have the power to know the count also in one go. But Moore-Voti giving you the elements, not the count. So to identify the counts of the dominant elements, you have to iterate one more times. But okay, what happened? And on space part, it will giving you the advantage. So the space complexity of mood vote is, I have to say, big of 1. But here on these solutions, we have the space of big of n. But yeah, on interview, I should like basically want, like in this particular questions, if you guys able to explain that there are 2 algorithms exist, and you can check with your interview if he or she is good to hit some mode hit on the time, so that they can optimize the space. Then on that case, you can say the mode vote, and they want like the mode optimized time, and for that they can hit some portions of space complexity. Then tell them this solutions, like, but please give them the taste of there are 2 solutions on your brain, and you can able to like implement any of them, and based on their choice you can give the respective solutions, respective algorithms. Yeah, so please try to like explain the things on this way, like name the variables like this way on the interview, so that basically make your code quality on the different levels on the other candidates. So please do that, and if you are able to understand till this point, so which I am going to tell on the all the videos, please subscribe to our channel, and please turn on the notifications when we are going live with our next video. So that's it for today's guys. Bye. Let's meet tomorrow with another question. Sure.